We talked in the last lesson about how to graph rational functions, and we had all of these different steps that we went through that we, were factoring and simplifying, finding vertical and horizontal asymptotes, intercepts, and then finally putting that all together and graphing it. Now, I want to talk a little bit more about horizontal asymptotes. So remember, we had these three rules. If the degree of the numerator was less than the degree of the denominator, that meant that the horizontal asymptote is y equals 0. And if the degree of the numerator was equal to the degree of the denominator, the asymptote was the leading coefficients. And we did several examples with both of those. The one that we haven't really talked about a lot yet is if the degree of the numerator is greater than the degree of denominator. If this is the case, there's no horizontal asymptote. But there might be a different kind of asymptote, and it's called a slant asymptote. So I want to show you one of these. I've got it over here on Desmos. So I've got this function x squared over x minus 2. And you can see that function, the degree on top is 2, and the degree on bottom is 1. So the degree on top is greater, so this has no horizontal asymptote. And you can see that here in this problem, that there's not a horizontal line that this is getting closer and closer to. Now, there is a vertical asymptote, and we can see that just looking here at the function. If we set the denominator equal to 0, we get x equals 2. So there's that vertical asymptote. And it also appears there's another asymptote, but it's kind of at the slant. It looks like that. So that's what happens sometimes with some of these functions, is there's not a horizontal asymptote, but there's an asymptote that's slanted. So we call it a slant asymptote or an oblique asymptote. So we're going to work on how to find those. So on your notes, if we go to, I think it's like the third page, just got to find it. Here it is. And this tells us that if the degree of the numerator is exactly 1 more than the degree of the denominator, then there's a slant asymptote, or an oblique asymptote is another name for that. The way we find that is we're going to use long division. So let me walk you through these problems. We're going to do it exactly the same as we did the other problems. We're going to start by finding our vertical asymptote. Our vertical asymptote is found by taking the denominator and setting it equal to 0. And so we get x equals 1. So I'm just going to go ahead and put that in here. Now, our horizontal asymptote, the degree in the numerator is 2, and the degree in the denominator is 1. And so since the degree on top is bigger, that means there is no horizontal asymptote. So we're just going to write none. Now, the degree on top is exactly 1 greater, so that means it does have a slant asymptote. So we're going to find that. I'm going to have to do my work somewhere and then erase it. We're going to find that using long division. So I'm just going to use this space over here, I guess. So x squared plus 4x plus 4, and we're going to divide it by x minus 1. Okay, so remember with our long division, our goal is to get an x squared right here. So what times x gives us x squared? Of course, it's going to be x. So x times x is x squared. X times negative 1 is negative x. We draw the line and change the signs. Gives us 5x. We drop the 4. And our next goal is to get a 5x. So we're thinking what times x will give us that 5x. And of course, it'll be a positive 5. So 5 times x is 5x. And 5 times 1 is negative 5. Draw the line, change the signs. And for this problem, you get to ignore the remainder, okay? We don't care. This is the slant asymptote. So our slant asymptote is y equals x plus 5. So we're going to come over here to 5. Our y-intercept is 5. It has a slope of 1. So this is what our slant asymptote looks like. Make that a little bit bigger, okay? So either our graph is going to be here and here, or our graph is going to be in the small section, okay? So either here and here. Okay, so we just need to figure out which one it is. So let me pop back up there so we can see it. So we can do the same thing we were doing before. We're going to find x-intercepts and y-intercepts. So remember, to find x-intercepts, we plug in 0 for y. We're going to multiply both sides by x minus 1. So we get 0 equals x squared plus 4x plus 4, which I think that'll factor. Oh yeah, it does. It's x plus 2 times x plus 2. And we set those both equal to 0, and we get x equals -2. So our x-intercept is -2. So there it is. All right, and then we want to find the y-intercept. I just don't have a lot of space to work with, so I'm just going to erase that. To find a y-intercept, we're going to plug in 0 for x. So we get 0 squared plus 4 times 0 plus 4 over 0 minus 1. So our y-intercept turns out to be -4. So down here. Okay, and that is enough information to see what's going on, okay? These points are going to get closer to that asymptote, and then they're going to turn and get closer to that asymptote. Now, there's probably some points on the other side we should get to. I forgot to write this down. The y-intercept is y equals -4. Okay, so to find those other points, we're just going to just make a table of values and plot some more points quick. 1 is my asymptote, so I'm going to plug in 2 and 3 and just see what I get for those. So let's see, I think 16, and when I plug in 3, I get 9, 12, 21, 25, something big, okay? Did I do those right? 4, 12, 16, yep, that was right. Okay, so I get 216, which is way up here. Okay, so the other graph is going to be this direction. Okay. In the next video, I'll show you how to graph the other one. I need to erase and make some space for it.